Hello, everyone, and a warm welcome, and thank you for joining day 2 of the Lightning Talks. My name is Zach Shwirab-Conti, and I'm a Turing Research Fellow at the Alan Turing Institute, and I will be your host for this afternoon. I promise to keep the lightning puns to a low voltage. If you have not yet grabbed lunch, please feel free to do so and bring it back in here. All right, we've got 7 striking talks today, each lasting 7 minutes, and the topics will range from policing to the arts. We've got a packed schedule, so let's get zapping. I'm really pleased to introduce your first speaker for today, Martin Stoffel, who is a research data scientist at the Alan Turing Institute. And Martin will talk to us about AutoEmulate, accelerating digital twin simulations. The floor is yours.
All right. Thanks a lot, Zach. So let's dive straight in. So if scientists and engineers want to understand the world, they make simulations. And these simulations, because the world is very complicated, these simulations are very complex. So in whatever field we look in, engineering, climate, biomedical sciences, we've got like complex simulations. They run complex mathematical models with lots of equations. And this means they are actually like very slow. So often they take hours or days or even weeks to run, and they are computationally very expensive. So you often need high-performance computing clusters, loads of cores. And that, of course, means they are, in a way, very unpractical. So if you want to explore the system a little bit further and you want to know how the parameters interact and run it over and over again, then these simulations are unpractical. And also, like for the future, if you want to have them in real-time applications, like we heard yesterday in the cardiac digital twins talk, they are just too slow. But there's a solution to the problem, and that's, of course, machine learning. In our case, it's actually more specific. It's to build an emulator model. And for those of you who haven't heard about emulator models yet, the idea is actually very simple. You've got the original slow simulation indicated by the tortoise, and you basically give it some inputs, you get some outputs. This is a slow process. You give it more inputs, get some more outputs. At some point, you might have a proper data set of inputs and outputs, and you use that to train a separate emulator model. And hopefully, that emulator model is actually much faster and much cheaper than the original simulation. So you can use that afterwards to input your data and get new data out much faster. And hopefully, the data that you get out is like fairly similar to the data you get out of your simulation too. And there's like one major problem about this. Like any model essentially could be an emulator. And we go from like very simple regression type models to very complex deep learning, neural network type models. And we don't know which one is actually the best emulator. And that's exactly the problem that our package, AutoEmulate, and our project tries to solve. So this is AutoEmulate. It's on GitHub. And it's basically an open source Python package. We're developing it at the moment. And the whole idea behind it is to actually make emulation really easy. And what it does in the background is that it automatically fits and optimizes lots of different machine learning models to find you the best emulator for your simulation. So how does this work? This is a toy example. Let's try to emulate a rocket simulation with AutoEmulate. So we've got like a rocket in the garden, and we want to know how the thrust we put in and like the launch angle of the rocket impacts how high it goes, so the maximum altitude. We've got like lots of standard equations for that. We're making a simulation, and we use this simulation to create some data points. So this is all very slow because it's based on sort of traditional simulations and mathematics. So we make data point after data point. At some point, we might have like 20 data points, and we have like a rough impression of what is actually the relationship between thrust and launch angle, how they're related to the maximum altitude that the rocket goes to. But it's not a complete picture, right? It's just like a few data points. And it took a long time. So what we want to do is actually take this data and put it into AutoEmulate. And this is how it works. AutoEmulate is like a very simple Python package. It's very low code. So you basically just have to set it up. And what it needs at its minimum is just the data we just produced. So x and y's. X are the inputs, y's are the outputs. And then we can basically just run compare and get our best emulator out of it. And it does a few things under the hood. And we can actually check what it did and how well it worked. So we can see that it basically evaluated lots of different models. And in this case, the Gaussian process regression was the best emulator model for that given simulation. We can also do lots of plots. So you can see how well the model is doing, like on an independent holdout set, for example, and just look at this visually. So it's very simple, just a few lines of code. And then we can go ahead and take our emulator and basically simulate much more data. And it's a little bit complicated code, but it's actually very easy. So what we do here is we just simulate loads of data points. So we get like 10,000 data points. This goes really quick. We put them all into our emulator that we just created to get some outputs. And because we have now 10,000 data points instead of just 20, we can get a much more complete picture of the relationship between all the variables and how the simulation actually works. So this is basically the whole idea behind the package. To just sum that up, maybe the thing to take away is that these emulator models are fast approximations of like complex simulations, and any model can really be an emulator model. And that's where AutoEmulate helps with. It makes emulation very easy. It's very simple initially, but it's also very customizable. So it's integrated with the scikit-learn ecosystem. So you can use lots of their tools to modify the tactics for cross-validation and data pre-processing and all sorts of things. It's open source, so it's online. Everyone can use it, and contributors are very welcome. What we're planning for the future is we want to have like some more very cutting-edge deep learning models. So there's lots of development in this direction going on because it's so important. And we want to really make this package an end-to-end application. So we want people to go in, give the package their simulation, and get out an actual analysis, like a sensitivity analysis or something like that, where the emulator is just an intermediate step. Yeah, so thank you for listening. AutoEmulate is part of the TrickDT. I don't want to spell it out. It's like a very long word, but that's basically our digital twin cluster. We had like lots of good collaborators on the project. And yeah, lots of discussions and data sets from people from different institutes. So yeah, thanks to them too. All right, thank you.